Hello, welcome to another video. It is, show you on there, 6:39 on Saturday the 27th of January. See, they're just walking up to the news that Jurgen Klopp is going to leave Liverpool at the end of the season. Sad times. Here is the state of the fridge. I got a Hörmar in yesterday. So I've got the kiwi out here, I've got the eggs, just cooked some chicken breast. Got the tofu, apples, tomato, blueberry. I got some black rice that I cooked yesterday. I got the world's greatest breakfast there, the chia seed, the oatmeal, the blueberry, the kiwi. I've got some egg here that I just cooked, that's 4 eggs in there. I've got some sweet potato, actually purple potato. It's kind of left over, but that's a good snack. And then in here, let's just bring you in a little bit closer. I've got the world's greatest lunch, or the ChatGPT lunch as it has become known. I've actually got 2 portions there, so I'm kind of set for today and possibly tomorrow as well. I've got a protein shake, I've got some orange juice. Not sure how good that is for me, but sometimes when exercising you need a bit of energy. I've got the Gatorade as well, the sparkling water, lemons for the flavour to squeeze onto the food, onto the ChatGPT lunch. Still got a bit of a cough, but I'm not going to let it get in the way of today's main topic, which is work done. We remember that work done is force times distance moved in the direction of the force. So what I'm going to do is go through a little demonstration of how we do work and also the concept of power. Let me just adjust that there. Okay, that's about okay. So I've got 2 5s here, 5 kilograms, and then 2.5. So I've got 15 kilograms of the plate. I think the bar is about 5 kilograms, so I think this is 20 kilograms here. I'm going to curl it up, and I think just about might get away with this. That distance from here all the way up to here is going to be a half meter. I'm going to say that's about 50 centimeters. Okay, so I grab the barbell, which is feeling a bit heavy. I've already done a full workout today, so this is feeling a little bit on the heavy side, but let's try this. And then I'm going to curl it up like this. 1, 2. I'm trying to do a rep every second. There are about 3, 4, 5, 6, 7, 8, 9, and 10. I'm going to put it down there. So we've got, as we mentioned, 15 kilograms of plates, 5 kilogram bar, 20 kilograms. That's not a weight, that is a mass. To get the weight, the formula we need, weight equals mass times by gravitational field strength, which is 10 on the earth. So I've got 200 newtons of weight up and down. So to counteract that, I need to apply a force of 200 newtons to lift that barbell up half a meter. 200 newtons times half a meter is 100 joules of work that has been done. I'm going to tilt the screen a little bit. So 100 joules of work. I did 10 reps. So that's 100 joules times 10 times. That's 1,000 joules of work. And you can hear from my breathing that I am, fairly out of breath, but not, ridiculously out of breath. And so 1,000 joules of work. We say in about a second for each rep, so maybe 10 seconds. And so we can work out the power. 1,000 joules in 10 seconds. Power is work done per unit time. That's 1,000 joules divided by 10 seconds is 100 joules per second, or we know that the unit of power is watt. See, these plates here always slide off. See if you can tell me in the comments why you think that it is that this plate always seems to slide down. And now what I'm going to do is do the same again. 200 newtons, 10 reps. I'm going to try to do the reps in a shorter time. I'm going to say half a second. I'll let you be the judge if I complete that. Okay. I'm fairly sure that that was not half a second for a rep, but we're going to pretend that it was. Now we can ask ourselves, what was the work done? And the work done was exactly the same, right? The weight didn't change, 200 newtons. The distance that I lifted it up didn't change, half. And you see I'm more out of breath than half a meter. So how is it that I'm more out of breath even though I've done the exact same amount of work? Well, if that was half a second per rep, now at the time taken in total was 5 seconds. And so the power is that work done. I'm trying to recall 100 joules times by 10, 1,000 joules now, instead of divided by 10, is divided by 5. So divided by 10 would have been 100 watts, divided by 5 is 200 watts. So I doubled my power output. I doubled the rate at which I was delivering work, and that is why I am significantly more out of breath. It is the power, the rate at which you do work, which will determine your breathing rate and your heart rate, okay? So remember, work done is force times by distance. Power is work done per unit time, okay? So next time you try some exercise, double the rate at which you do it. Notice how out of breath you are. Go ahead and calculate the work done and then the power, and then realize why it is you are more out of breath when you speed up the number of reps, or you're running faster, rowing faster, cycling faster, whatever it happens to be, okay? Right, I'm going to, what am I going to do? I'm going to have a rest, and I'll see you next time.